So, as many of you know, I suppose you all know, I believe that we're going to find life on an alien world. I believe we're probably likely to find it in the next decade or so. We could find it within months. We've got the James Webb Space Telescope now in orbit around the Earth, and we have that in space. That incredible machine. You know, we'll be able to do astounding things now. And the more I think about it, the more I think, you know, space is going to be absolutely vital to our future progress, to our future prosperity as well, to our security, also to our, corporeal security, the security of our rights and possessions, the security of our information, But it'll also be vital to our sustainability, I think, in terms of being able to generate fusion reactions and harness that sort of energy. I mean, if we can do that, if we can really sustain nuclear fusion in space, and, you know, I suppose, like, the upshot of that idea, or like, if you like, the implication of it, or what we'd be trying to do ultimately with it, is, I suppose, maintain small stars in space to, you know, manufacture, in essence, elements that we need, elements of the periodic table that are relatively scarce. And if we want to take prospects such as mining asteroids also seriously, and perhaps moving some of our manufacturing to space, and, you know, heavier industries like these, petrochemicals also. If we're in need of those, you know, mining Titan, we're going to do that at some point. We'll need much bigger rockets than what we have at the moment. That is just the truth. That's the only way we'll get that equipment up there. We need big rockets, and perhaps we can build these. Will it be expensive? It will be hugely expensive, of course. Will it come in at under 100 billion? I doubt it. No, it wouldn't. Now, to get one of these, maybe we can build an intermediary stage, a huge experimental rocket. Something about the size of one Canary Wharf. A rocket that big. Maybe that could work. Or maybe we need to build something bigger still. But then again, we need to integrate this technology of reusable rockets, landable rockets. Rockets that we can get to dock with third stages, is it? Or second stages out in space. And, you know, place a payload upon it, and then it retracts back down and lands on the Earth. That would be really the ultimate way forward, would it not, in the future? If we're to, you know, be mining materials, manufacturing things out of those materials, all in space, potentially, and then back to Earth, bringing them down again. Either, you know, the finished products or components, if they're not required in space, frankly. And, you know, this is how the landscape of the solar system could look in the future. We don't have all this empty space, right, in which we just float, or in which objects just float naturally as they're carried around the sun by the sun's gravity. And there's an awful lot I suspect we can do in the area available to us in space. And, you know, it could be a sort of highly productive zone, if you like, couldn't it? Perhaps. And then there's the prospect of actually moving out further into the rest of the galaxy, exploring the rest of the Milky Way. You know, this plenum of stars, this 100 billion stars or so in the Milky Way galaxy. And these strange objects, like supermassive black holes at the centre of them. I'm trying to get to the bottom of those and what those are. You know, and putting, great bigger experiments in space, larger machines of one form or another. You know, do we need like rail guns to get probes and spacecraft to other solar systems? To get them up to light speed, then how do we slow them down again? Parachutes. Is that an option? Could that work? How many would we need? Or how big a parachute would we need to slow a spacecraft down from light speed at the right time so it gets within a solar system, it doesn't burn to a crisp, and doesn't fall into the star? Maybe, I think it's probably the issue, isn't it? Or a gas giant, frankly, that'd be kind of, it could be potentially bad. Or any objects, really, to, you know, yes, navigate to other solar systems, get within them and explore them. Surely we can do this. I think we can. We certainly can. I'm a big optimist, and I always have been in my life. And, you know, everyone around me, everyone I've known, has always been a pessimist. You know, it'll never happen. It would, and it's just all not possible. That's the major thing. Like, you haven't, I know you haven't looked into it. I just know they haven't. They haven't searched the relative tensile strengths of things like aluminium versus carbon fibre, and fiberglass even, and various plastics that we can manufacture. I know you haven't. Like, why saying that? Once you're like, Jesus Christ, what could the future be like? And, you know, plastic is obviously, it's cheap. Like, I would like cheap, nasty rockets. Cheap and extremely nasty rockets. Or like Titan rockets. Nah. What would the rocket be called? Who would be making it? Like Boeing, Lockheed Martin, Northrop Grumman. Aerojet Rocketdyne. Aerojet Rocketdyne usually make the engines. I thought this also, like, in my my Jetsons movie idea. George Jetson, I buy a component for his car or something. And, like, you know, just like gets new one. Like, what is it, like 2 twin turbo thrusters? And at the end, it's like, checking. Thank you for shopping at Aerojet Rocketdyne. It does sound like that. It could be like, that's a weird sort of space punk movie. I think, I don't know, or something. I think it's a good idea. Just like Jetson. A little George Jetson movie. Kind of fun. I really like that.